All right. So I'm going to start off with um, rates of change. Some question. I'm going to do some questions from the maths workbook that you guys have. Thanks to Leo for encouraging me to do these questions. The first set of questions are from rates of change. They are starting on page 188. First question is number 6. So it's about a conical water tank. So a conical water tank of top diameter 6 meters and height 8 meters is fixed in position as shown, which I'll draw shortly. If the water flows into the tank at a constant rate of 6 cubic meters per minute, how fast is the depth of the water increasing when the depth is 4 meters? So I want to visualize it. It's a cone, kind of like water is filling in a cone. Okay, so there's water filling here, and the diameter of the top of the cone is 6 meters, and the height of the cone is 8 meters. That's that height. Right. So if you want to imagine the height of the level of the water is h, for example, then the question actually is, you have to find the change of height, which is, I suppose, dh, rate of change of height. So rate would be dt, so dh over dt. So rate of change question usually is a chain rule question, so you have to see what you have and what you need. So we need dh over dt as our question. What do we have? In the question it says you have the water filling in at a flow of 6 cubic meters per minute. So the units usually are a good indication of what the rate is. So the unit is 6 cubic meters per minute. Cubic meter per minute would be dv over dt. So dv over dt. Now let's see if we can find dh over dt by using dv over dt, and so we need h. So if you have dh, so maybe dh over dv or dv over dh. So the dv's will cancel and end up with dh over dt. So most probably you'll be able to find dv over dh, flip it, and you end up with that. So once you've ascertained your chain rule, you can get to work. Okay, so if you drew a cross section of the cone, and let's say that if you want to look at the height of the water only, and let's take that out from there, you end up with a right angle triangle. Let's say this angle is theta, and so that would be the height of the water, and that would be the radius of the that will be the radius of the water. So hang on. Right, so if you want to find or write an expression in terms of h and r, you can use tan theta. So you can see that tan theta equals opposite over hypotenuse, r over h. Similarly, if you use the big triangle, I'm going to just use a different color just to superimpose. If you want to use the big triangle there, that one, since the diameter is 6, so that would be 3, and the total height is 8, so that will be 8, and that angle still will be theta. So if you use the big triangle, these, as you can see, are similar triangles. If you use the big triangle, you can write down tan theta is equal to 3 over 8. All right. So using that, you can actually equate those two and form either r as the subject or h as the subject. And you can see from there that r over h equals 3 over 8. Okay, cool. So from here you can see that r is equal to 3 over 8 h, or h is equal to 8 over 3 r. whichever way you want to work on. All right, I'm just going to go change the color and continue from here. Okay, cool. So the next step for you would be, so in order for you to find dv over dh, which is that one, we have to form the volume function for the cone. So the volume of a cone is pi r squared h over 3, or 1/3 pi r squared h. Okay, so you can substitute r and put h in terms of r. So if you want to highlight, for example, if you use that r and substitute, you end up with v is equal to pi over 3, r is 3 over 8, so 3 8 h squared times h, and if you simplify, you end up with the v is equal to 9 pi h squared over 24 times h, and so if you simplify all that, you end up with v equals 3 pi h squared over h squared over 64. So that becomes your function that you have to differentiate with respect to h. So you can get your dv over dh. All right, this is a cool. So let's differentiate that. So if you go dv over dh, you end up with 3 pi over 64 is your constant. Therefore, you let that be. So you go 3 pi times 2 h over 64, and that equates to dv over dh equals, if you simplify all that, you end up with 9 pi h over 64. All right, I'll write that down in the next sheet. So dv over dh equals 9 pi h over 64. Right, so you use the chain rule that you've developed, which is dh over dt is equal to dv over dt dot dh over dv. Wait, yes. And then the dv will cancel, you end up with dh over dt. Cool. So dv over dt is already given as 6 meters cubed per minute. It's in the question, so 6 meters cubed per minute times dh over dv is not given. You're given dv over dh, so you flick. So dh over dv equals 64 over 9 pi h. Okay, let's substitute that times 64 over 9 pi h, and if you multiply all that, you end up with 128 over 3 pi h squared. 3 pi h squared. Okay, so the question actually asks the rate of how fast is the depth of the water increasing when the depth is 4. So to be able to answer that question, you have to substitute 4. So when height is equal to 4, find dh over dt. So let's substitute. So you go 128 over 3 pi 4 squared. You substitute all that and you end up with 0.849 meters per minute. Meters because of space. And there you go. That solves question number 6. Okay, so the next question we will be looking at is on page 189, question number 10. So the question reads something along the lines of: a rocket is launched vertically, so it goes up like that. So there's your rocket, which goes up straight, and there's a there's a launch site which is 200 meters away as an observation deck. So That's a launch site there. Sorry, observation deck is there, launch site is there. Tracking device is at the observation station, which is here. It tracks the rocket, so in a way it kind of, if I change some colors to maybe yellow, is it tracks the angle changes and it tracks the rocket up. So what do you have? So it says the angle theta is increasing at a constant rate of 0.5 radians per second. So d theta over dt equals 0.5 radians per second. Units are important here, I suppose. Moving on, you have to find out the angle, right? You have to find the speed of the rocket at the instant theta is pi over 4. Okay, cool. So what does that ask us to find? It wants you to find the speed. Speed is change in distance over time. So pretty much since it's going vertical, we are going to use h. So it asks us to find dh over dt that way. And that is our question. So in order for us to find dh over dt, we're going to use d theta over dt. Okay, cool. D theta over dt. And so what is we need to get rid of the theta, so there'll be d theta, we need a dh on top, and that makes our equation. So that's our chain rule that we are going to use to solve this question. Cool. So we already know, I'm just going to change the color, we already know d theta over d2, which is dt, sorry, which is 0.5. So we need to find dh over d theta, okay, or d theta over dh, and we can flip it. Okay, so let's form an equation in terms of this right angle triangle where we can connect theta, h, and 200. It's pretty straightforward. You can see tan theta equals h over 200. Okay, cool. Right. We want to make h the subject, so h would be equal to 200 tan theta. Okay, right. So that's pretty straightforward. All you have to do is now differentiate. So let's take it this side. So if you go dh over d theta, and if you differentiate there, what you get? So if you all have to do is just look up the formula on the formula sheet. So if you differentiate tan theta, you end up with sec squared theta, or secant squared theta. So you end up with 200 sec squared theta. Okay, cool. All right. So now all we got to do is substitute in the formula. So let's write the formula down on the next page. It's quite messy here. All right. So dh over dt is d theta over dt. So dh over dt equals d theta over dt times dh over d theta. So let's go back and check. So d theta over dt is 0.5. Let's substitute. Let's just use a different color now. 0.5 times, and then d theta over dh is that one, 200 sec squared theta. Okay, 200 sec squared theta. Now if we make it simpler, so half times 200 is 100. Sec squared is the same as 1 over cos squared, so I can put that down simply because we will have to substitute. So cos squared theta, so dh over dt, you got the expression for how fast it's moving with respect to the angle. And the question says, find the speed of the rocket at the instant when the angle is equal to pi over 4 radians. What do? Well, we substitute. So we'll end up, sorry, I think I made a mistake. Sorry, right, so we substitute, so we go dh over dt, so we go 100 divided by cos, okay, so one thing you got to remember is cos squared theta is the same as cos theta squared. This is the short form. So when you actually do the calculation, you got to use this part. So cos of pi over 4, which is 45 degrees. Make sure your calculator is in radians. If you use pi over 4, so you go 100 divided by cos pi over 4, n squared. Okay, and if you do all that, you end up with 200 meters per second. Cool. All right, so there you go, and that's the end of question number 10. Moving on. Okay, so let's do a couple of questions on maxima and minima, and a quick visual would be, if you have a function, so when it goes on top hill, it's a hill that means something. If it's a valley like that, it means something. So one of them's a maximum, one of them's a minimum. This is a minimum, and that's a maximum. Cool. So pretty much we have to just use our tools to find some form of calculation for maximum and minimum. And the thing that you have to remember from last year is that you got to make sure that the gradient at both is equal to 0. So pretty much all you do is you form an equation, form an equation, differentiate, equate to 0, and pretty much solve. Okay, moving on. So the first question would be, all right, so the first question is on page 195. Question number 2, there's a triangle. It's a right angle triangle. It's a Pythagorean triple or Pythagorean triad, because this side is 5, this short side is 12, and the hypotenuse is 13. So the question says, if you form a rectangle with the base x and height y, what is the greatest area that rectangle can have? What that translates to is, find the maximum area. It's a maxima. So maximum area that rectangle can have. So the starting point is area of a rectangle, given that would be x and that would be y, would be x times y. So what normally we do for this is we have to form an equation where we have only x's or only y's, preferably x's. So how do we go about doing something like that in this situation where we don't have any? There's actually two main ways of doing this. Though I'll only teach you one, and then if you know the other method, great. If not, then I can go over that on Thursday or later. So the method I try and do in this instance is I try and use this as my xy axis, and I want to form the equation of this line. You know what? So that I can find that point in a way. So right, how does that help? So this is my c, which is 5. This is 0. The gradient would be rise over run. So I mean, you can figure it out from there. The y equals, so the gradient will be negative. So I can either write it 5 minus 5 over 12x, or I can go minus 5 over 12x plus 5. And that gives you pretty much a function which can then give you some coordinates, or which you can rearrange to actually find what you need for you to substitute here and then differentiate. So if you replace y with that, I'd rather rearrange it because it's easier. Y equals 5 minus 5 over 12x. So area is equal to x into 5 minus 5x over 12. And so that makes it 5x minus 5 over 12x squared. So that's I dash of x. And you equate this to 0. Okay. And when you equate this to 0, you can... Wait. What am I doing? Pause. Sorry, my bad. I haven't differentiated it yet. This is just a function. Sorry, this is not I dash. This is I. So I'm getting ahead of myself. Sorry, this is like 10 o'clock at night and I'm a little bit fired, so bear with me. So this is the area. Right. Now let's differentiate I dash of x. So 5 of x, if you differentiate, you get 5. Minus 5 to 10 over 12. 10 over 12 is 5 over 6x. Okay, now you equate it to 0. All right, that's better. So then you end up with 5 over 6x equals 5. You can take this and to the other side becomes positive, and then shift it left to right, and then 6 goes up, 5 comes down. You end up with x is equal to 6. So you can do your steps. What was the question? Maximum area. We found x. We gotta find y. How do we find y? We substitute in this equation. So from here, y equals 5 minus 5 over 12 of 6 times it by 6. So you end up with 5 minus 30 over 12, which gives you 5 minus 2.5, which gives you 2.5. So the area, take this out. Let's change this to make it slightly different. So the area is x times y, which is 6 times 2.5, which is 15 centimeters square. I think everything is in centimeters. And there you go. Cool. So that's a maximum question. Moving on. Okay, next question, page 197. It's trying to fit a cylinder inside a cone. The radius of the base of the cone is 5 centimeters. So the radius, so if you do the radius of the cone is 5 centimeters, and its height is 12. So from there to there is 12. So find the maximum volume of the cylinder that you can have. So that's a 3D diagram, as you can see. So that's your cylinder right inside, and for you to make any sense of it, what you have to do is you have to, I will drop this off, draw a diagram which gives you a little bit of a two-dimensional diagram to see. So if I actually use that line, that could be my y-axis, and it will look very similar to what we just did a while ago, with very similar numbers too. So this is your r equals, sorry, my bad, no, the cone, sorry. Right, so this is your radius of 5, that is your 12, and so that line would be 13. If you could remember, it's just on sideways from the other question. So this is your x and this is your y. Cool. So the only difference is that one was an area, this is a volume question. So how do we go about solving this? Okay, let's move on to the next page and figure out. Okay, so I just use black. Cool. So the volume of a cone is 1/3 pi r squared h. Okay. The volume of a cylinder is pi r squared h. Okay. So in this instance, if you actually looked at your diagram, I'll make a smaller one. So the radius for the cylinder is x. So it will be pi x squared y. So there will be y and there will be x. So the radius will be x and the height will be y. Okay, cool. So let's form the function for the volume of a cylinder and eliminate y and see where we go. So volume of the cylinder, this is cylinder, would be pi x squared y. So we have to find how y and x are related. So this would be 5, that would be 12. So we can write down the linear equation for that would be y equals 12 minus 12 over 5x, and we can substitute that. Let's change colors a little bit. So we can substitute that in place of the y here. So we end up with v equals pi x squared 12 minus 12 over 5x. All right, let's expand. V equals 12 pi x squared minus 12 over 5 pi x cubed. So you get two variables in that function. Step next, changing color. Differentiate. So you go v dash of x, or dv over dx if you want to. And then you got 12 to 24 pi x minus 12 3 is 36 over 5 pi x square. All right. What do we do next? Equate this to 0. We're going to find the maximum. Okay, so what we do next is, I can see 12 pi x is common, so you can go 12 pi x to 2 minus 3 over 5x equals 0. So 12 pi x equals 0, and then 2 minus 3 over 5 pi x equals 0. So sorry, x equals 0. So you end up with 3 over 5x equals sorry, 2. So that'll be 5 to 10 divided by 3. So x equals 10 over 3. One of the solutions is x equals 0, but we can't use that. So cool. So when x equals 10 over 3, I want to find y. Let's go up here. We go to y equals 12 minus 12 over 5 times 10 over 3. You substitute all that, and you end up with 4. Cool. So what is the maximum volume? So then you go v equals pi x squared y. Pi x is 10 over 3 squared, y is 4, and you plug that all in, you get 139.6 centimeters cubed. All right, cool. So form the equation, which is that one, of the cylinder, volume of the cylinder. Eliminate y, so that either x or y, doesn't matter. How to do that? You find a relationship between x and y, using the lines there, and then expand it so you can differentiate. Then differentiate, equate to 0, solve. You end up with two solutions. One of them is x equals 0 and x equals 10 over 3. You can't use this because it's 0. And then you find y, and then you actually find the volume, because that's what the question asks for. He asked for maximum volume, and there's your maximum volume. All right. Okay, the next question is on page 197. It's question 9, and it's about an ellipse. It's about a rectangle inscribed in an ellipse. The equation of the ellipse is given, which is x squared over 4 plus y squared equals 1. So the complete would be x squared over 4 plus y squared over 1 equals 1. It's center 0, 0, so it's same process, except it might be a little bit more weak. Okay, so that's your function. I'm going to multiply throughout by 4 just to make it more top heavy. So if you multiply by 4 throughout, I end up with, right. So I end up with x squared plus 4y squared equals 4. This is just for me, but you can actually work with the first equation, and there's nothing wrong with that. Okay, now the area of the rectangle. I'll change font colors just to make it slightly different. Okay, the area of this rectangle, this one right here, it's quite important. The base is x, sorry, my diagram is terrible. So it's x and minus x, so there'll be 2x. So 2x times, same thing for y. There'll be y there, so there'll be 2y. So you end up with area equals 2 times 2 is 4xy. So what you have to do next is you have to replace y or x. I'm going to replace y. So how do I do that? I take this equation and I rearrange it. So I go 4y squared. No. Hang on. I'm not going to replace y. I'm going to replace x, simply because if I replace y, I'll get a 4 at the bottom. You can definitely do that. It's just that it's going to take you a little bit longer. So I am going to go x squared is equal to 4 minus 4y squared. And if I square root that, I end up with, but actually, I can just take 4 out, can't I? I can go x squared equals 4 into 1 minus y squared. And then I square root, I end up with 2. So I got x equals, if I square root that side, square root this side, square root of 4 is 2, square root of 1 minus y squared. Yeah, I told you it's going to be a little bit tricky. And then I substitute back here. So my starting off equation would be area equals 4xy. Let's go back. X equals 2 square root of, and x equals 2 square root of 1 minus y squared. Okay, let's plug it in. So in place of x, I'm going to put all that. So I go area equals 4 times 2 square root of 1 minus y squared times y. Okay, so I can put the y in front. I end up with area equals 8y times square root of 1 minus y square. If you have replaced x, it's totally fine. Sorry, if you've replaced y in place of y input, and then you've formed it with x, you'll end up with similar things, except you'll have some denominators. Again, you can solve it, no problem at all, but it just makes my life a little more tedious. So try and not have too many fractions in there. Okay, cool. What next? Well, you have to differentiate. You will quickly notice that this is a product rule scenario. So I'm going to change colors just to show you. U times V. Let's do that. So you've got E dash of Y, or dA over dy. In order for you to do that, let's go U equals 8y. V equals, I'm going to put brackets, 1 minus y square to the power half, just to make it easy. Square root, same thing. U dash would be 8. V dash would be, well, chain rule, half 1 minus y squared to the power negative half, because half minus 1 is negative half, and then multiplied by negative 2y, negative 2y, just because I don't have space on the right hand side, which equals to 2 will cancel, you end up with minus y, 1 minus y squared to the power negative half. Okay. Let's plug that in terms, let's just rewrite that in terms of, I'm going to change color slightly to, okay, purple maybe. Let's rewrite that in terms of the square root symbols. So when you go u dash v plus uv dash, u dash v plus uv dash, doesn't matter as long as you cross multiply. I'm going to put the simple ones first, so I'm going to put that ones first. So you go 8 square root of 1 minus y squared plus, then I'm going to go these two. So that'll be 8y squared. So that plus becomes minus. So becomes minus. Oops, sorry, something happened. Okay, and I'll rub these off. Right. Minus 8y over square root of 1 minus y squared. All right, cool. And you equate that to 0, and then you can just take one of them the other side, and you end up with 8 square root of 1 minus y squared equals 8y over square root of 1 minus y squared. Change color to cancel. 8 will cancel, and you can take this and multiply. So that will look something like, the squares will cancel and square roots will cancel, and you end up with 1 minus y square equals y. Just give me 1 second. I missed something. This actually is y squared, because 8y times that y gives you square, and I missed that, sorry, and therefore this is squared. And so if you move this to the other side, it'll be y squared plus y squared, which will be 2y squared, which is 1, and divide by 2, and square root gives you y equals 1 over square root of 2. All right, cool. You can get a negative answer as well, but that's not important because not applicable is positive. So what next? So next, what we do is we find x. How do we do that? We end up with the x is equal to 2 square root of 1 minus y squared. Where did I get that from? I got that from here. Just to find x. And then I substitute 2 square root of 1 minus 1 over root 2 squared. 2 square root of, so 1 over square root 2 whole thing square would be 1 over 2. 1 minus 1 over 2, which gives you half. And so that becomes 2 over root 2 if you simplify. Okay, so let's go back. That's your area formula. So find the area. Change it to so area equals 4xy. In place of x, you're going to go 4 times 2 over root 2 times sorry, 1 over root 2, and so there'll be 8 divided by 2, which gives you 4cm squared. And there you go. Okay, cool. The next question is on page 197, question number 10. So question number 10 is about an equilateral triangle ABE, which is sitting on a rectangle formed by itself. So equilateral triangle would be that, that, and that. Sorry, and in there it wants you to find, it says the perimeter is linked, sorry, and it wants you to use this as x and this as y. It's y, so since that is equal to that, it'll be x, that'll be x, that'll be y. All right, so it says the perimeter of the pentagon ABCDE, which is ABCDE, is P. So the perimeter equals P. So the question is, you have to find the length x in terms of P that makes the area of this pentagon a maximum. All right. How do we go about doing that? Okay, so what we do first is we just write down the perimeter in terms of x and y. Right, so the perimeter is equal to how many x's there? It's 1, 2, and this is not y, sorry, this is x. It's not y, that is x. So that's 1, 2, and 3 x's. 3x plus 2y. Okay, so how do we actually get x and y, or how do we find some sort of commonality in terms of how we can actually tackle this question? All right, so the question actually is about area. So area of the pentagon is the area of this rectangle plus the area of this triangle, which is equilateral. So if you actually it's two triangles, so if you take this bit here and park it here, you end up with another rectangle actually. So I'll just take those out a little bit so that, yeah, right, so the area would be equal to x times y, which is the rectangle, x times y, plus it'll be this times the height. Now this is easy, it's x over 2. How do we find the height? Oh, we know this is x, we know this is x. We can use Pythagoras theorem. This is right angle triangle. So let's see what we can come up with. So that, let's say h, h is, or h squared is equal to x over 2 squared. Oh, sorry. Actually, it's the shorter side, right? This is the shorter side. So it'll be that minus. It'll be x squared minus x over 2 squared. So if you simplify, end up with x squared minus x squared over 4. So that'll be 1 minus quarter is 3 quarter. So 3x squared over 4 square root would be equal to h. If you simplify that, that comes to root of 3 over 2x, because the square root of the x will cancel out. You end up with the root 3 and square root of 4 is 2. So h would be equal to that. So meaning x over 2 times the height would give you that, which is half, and then times it by 2, which will give you the area of that equilateral triangle. So it will be x over 2 times root of 3 over 2x. Okay, so that's the expression for area. You have to expand and see what you end up with. You get xy plus that'll be 4 root 3 over 4x squared. Okay, that looks great. Now, so what's next? Well, we have to get rid of this y. Also, we have to include the perimeter in our function. The question says in terms of perimeter. That's a handy thing, so we can actually make that in terms of y and get rid of y. So that would be 2y equals p minus 3x. So y equals p minus 3x over 2. Okay, let's substitute in here. End up with area equals x times p minus 3x over 2 plus root 3 over 4x squared, which gives us if we separate the terms, it end up with px over 2 minus 3x squared over 2 plus root 3 over 4x squared. Okay, so we end up with 2x squared terms, as you can see from here. Let's move it to the next page. So I'll just copy it. Alright, so the next thing you have to do is you have to see what you can do with this in terms of seeing if we can factorize this. So if we, area equals px over 2, if you double these two, you end up with 6 over 4, and then you have minus 6 minus root 3 over 4 x squared. So what I did is I actually included this in brackets so I could factorize. This minus is important here, it's not a plus, because if you multiply that with that minus, you end up with a plus there. So that's a bit tricky, but you can actually get that done, or you can differentiate them separately, and that's totally fine. The only reason why I want to do that is because then I can end up with an accurate answer, not a decimal. Okay, next step is to differentiate. So a dash of x equals p over 2 minus, the 2 comes in front, so 2 divided by 4 by 2, so 6 minus root 3 over 2x, and then you equate that to 0. So that can go in a bracket, and this can go away. Okay, so if you move that to one side, you end up with 6 minus root 3 over 2x equals p over 2. The 2 cancels, and you end up with x equals p over 6 minus root 3. Sorry, 3. All right, and that's it. The question wanted you to find. What did the question want to find? Find the length, of x in terms of p that will make the area maximum. So you've done that already. Cool. All right.